Okay, so as promised, we have the star cut. And what you're seeing before you is I've made the square my usual way. You may have a better way of doing it, and that's all good. Um, I just, that's the way I like to do it. Um, the star cut falls into the square itself, as mentioned earlier, and it's just a series of lines that go to the corners and the midpoints of each of the sides of the square. All right, now, if you're my usual viewer, so to speak, you already know what I'm doing here. But just for the sake of being thorough, I wanted to go through the process of what the star cut is and what it can do. All right, and I had a quick look at this square before I put it together, and it's not 100% straight and narrow. For the purposes of this discussion, it will work just fine. So you can see I've attached two corners to the midpoint, two corners to the midpoint. I'm going to do the same thing. Sorry, I'm moving my sheet around on the camera. I'll do the same thing on the other sides until we get this nice pattern. Within the square. And it's nice for a couple reasons. I mean, it's from an artist perspective, it's visually appealing. Um, from a geometer perspective, it has a whole lot more going on. And I'm not thoroughly versed on all of the connections it can make. That might come in a later video. For the purpose of this intro, we'll just stick with the basics, absolute basics. But the key here to recognize in the star cut is that each one of these intersections is absolutely vitally relevant to the dimensions of the square and the circle. And I'll give you an example of what that means. If you look at, this is where I put my money where my mouth is, bear with me. If you look at the basics of the star cut, okay, we have from the edge to the midpoint. Okay. So really quickly, if we go from here to here, we should also be able to go from here to here to perfectly bisect the square. Okay, and you can see we do within reasonable error. So this midpoint, common sense, is halfway between the two edges of the square. Okay, no brainer. So this guy here, okay, this point here, this intersection, try and keep my camera from getting all blurry on you, would be 1/4. So we'll test that out. Okay, we'll draw one circle. And two circles gets us to the half, as you'd expect it to. In the middle, and finally to the edge, and you can see it went all the way across. So this is the halfway point. This is the quarter-way point. This is 1/2. This is 1/4. All right. Well, where's 1/3? If you go from 2 to 4, it'd be somewhere in the middle, and it's actually this point right here. If we take, I'm gonna mess up my star cut a little bit here, but if we go from this point to this point, draw a line across, and this is where it'll matter whether my square is actually square. So we found this point on the square. We draw our compass point to that intersection. Go 1, 2. And see how the circles? I mean, okay, I gotta pause here and just point out from the point where the intersection happens to the compass, we find the corner. See how that's related? Okay. When we go here, the circle that this draws comes right to the edge of the square. It all fits. When I come to this point, we get back to this edge. All right. So what that shows, you can see I'm a little inaccurate, but what that shows is that this intersection denotes 1/3 of the size of the square. All of these intersections will give you a proportion of the square itself. All right, that's why this is so important. If you can imagine ancient builders who didn't have a ruler, all they had was their wits and their tools, and maybe a long stick that they could stick in the ground with a rope and draw out a circle. If they could mark the points of the circle, the 12 points around the circle, to make a square, and then they could set up these lines within it, they could measure things like floor tiles, like bricks. They could build with this. It's an immensely powerful tool, and it's useful to understand how it works within the circles as well. So I just wanted to bring it up and say, you know, this star cut is quite remarkable, but also on a personal level, because I do like to make geometric patterns. If you want to ignore the math, you can start to do interesting things with it. So if I'm going to extend just the middle row of squares here, really quick, and I'll draw just one of these two squares. Maybe two, see how much time I got. I can get this edge down. And again, it really matters that your squares are square. Otherwise, it doesn't work quite as well as it could. You want to be as accurate as possible with where you put everything down. What have I done? There we go. Okay, so I've extended this square. Okay, this was on the center circle, and now this square is on the left-hand circle. If we do a new star cut, you can see that they start to interplay with each other in a neat way. And I just goofed. Of course I did. Dummy. Okay, I need the center line for this square as well. I got ahead of myself. Okay, I'm going to try and clean this up. All right, take two. the edge of the proper square. Same idea here. All I'm doing is just tracing out the star cut on the square right beside our original. And you're going to see a hint of something that I've been playing with for a little while now. You get these X's that start to form. Of course, the lines get really messy, so you do have to be careful of that as well. That's why you're not seeing a more detailed video on this yet, because it takes some setup. Most of it has to happen off camera, otherwise you're just watching me fumble around with lines. Okay, you see, you get these X's that form, and they're almost like the links of a chain. It's the best way I could think to describe them. If I extended this square out, which I'll do in a later video, you could see how the whole thing looks. You would see another X pattern form over on this side, and everything would chain together. And then there's this, depending on how long your chain is, you get these like almost starburst patterns on the ends that emerge. It's really kind of cool to see play out. You also get these diamonds that show up as the points of the star overlap each other. It's really, really cool. But that'll come in a later video. For the most part, if I remember off the top of my head, you can go to 1/11th the width or the length of the circle, the square, sorry, length or width, since it's a square. All of these different lengths between all are significant depending on where you start from. And there's even methods of squaring the circle. I'll put that in quotes because we all know it's mathematical impossibility, but we're estimating here. There are ways to use the star cut to do that, which I will get into. And yeah, like if you're building and you don't have a ruler, if all you have is a straight edge and a compass, you can still build a sound building of stable design. It's a really, really powerful tool. And this is just scratching the surface of it. I highly recommend, if you haven't already, Google the star cut and see what you can do with it. It's pretty cool. All right, I'll sign off for this one, and I'll talk to you later.